Hello everyone, I am Rupesh H of GM University, pursuing my BTech in CSE AIML. So today me and my teammates will be explaining you about the program which is parallel sort using shared memory. So these are my friends Sahil Khiroji, Rohit Itigi, Rohan DR and Guru Shankar AS. Now I'll be giving the introduction about this program. So basically parallel processing has become a cornerstone of modern computing, which enables the efficient execution of computational intensive tasks. One such task is sorting large data sets, like which can be time consuming when performed sequentially. This program demonstrates a parallel sorting approach using multiple child purposes to divide the workload. The task begins with the parent process, generating a large array of random integers, which are distributed into small segments. Each segment is assigned to a separate child process for sorting. To facilitate communication between the parent and the child processes, shared memory is used, allowing the child processes to access the array segments concurrently. After sorting, the results from all child processes are combined to form a fully stored array. This structure is particularly useful for sorting very large arrays as it allows the system to take advantage of multi-core processes, significantly improving performance. By employing process management techniques such as creating child processes, create process, and utilizing shared memory, create file mapping, or map view of file, the program provides an effective demonstration of parallelism on Windows system. So this is the introduction about this program. Now my friend Sahil will continue the rest. Thank you.
Thank you, Rupesh, for giving the introduction part. Now I will start with our program explanation. Here, hashtag include window.h. This imports Windows-specific APIs required for system-level operation like shared memory and process management. Hashtag include stdio.h provides function for input and output such as printf and fprintf for displaying message or errors. Hashtag include stdlib.h includes functions for memory management, malloc and random number generation. Here, hashtag define array size tells us define the total size of the array as 10 million elements. Number hashtag children, which specifies the number of child processors to be created, which is 10. Child array size divides the large array into equal chunks, each to be handled by a child processors. Function declaration void generate random array. This function fills the array with random numbers. It will be used to initialize the main array. Merge arrays. This is the placeholder function for merging sorted segments of the array. Main function int main array malloc allocates memory dynamically for main array to store 10 million integers. Generate random array main array comma array size fills the main array with random integers using generate random array functions. This prepares the array for sorting. Handle hmap file is equal to create file mapping. Allocate shared memory that can be accessed by both parent and child processors. Invalid handle value. This indicates the shared memory is created in the system paging file. Page read write. Grant read write access to the shared memory. Array size into size of int specifies the size of the shared memory block. Global shared memory names the shared memory so that child processes can access it. If hmap file is equal to null, fprintf stderr could not create file mapping object percentage %d ensures the shared memory creation was successful. Get last error. If the shared memory creation fails, this retrieves the error code, which is then printed to the console, which includes the totally includes the prepares the necessary libraries and macros. Memory allocation allocates memory of the for array and initializes it with random values. Shared memory creates a shared memory object so that child processors can access the same array data efficiently. Error handling checks the error in the shared memory creation and handles them gracefully. Now my friend Rohan will continue the remaining part.
Thank you, Sahil. I'll now explain the map that shared memory from the parent process. Map view of file. Maps a view of a file mapping object into the address space of the calling process, and the parameters are h map file that handles the file mapping object. Map file map all access grants the read write access to the shared memory and specifies the offset from the start of the file mapping. Array size of int specifies the size of the memory to the map, and the next result, a pointer is returned which points to the map shared memory. And let's check the error handling. It checks if map view official failed, logs an error message with get last error to retrieve the code, cleans up by closing the handle hmap file, returns 1 to indicate failure. And next I am explaining the copying data into shared memory. Mem copy. It copies the contents of the main array into the shared memory pointed to by shared array. This ensures that the shared memory contains the same data as main array that child process can it access. Creating child process information, structure to store information about each created process, including process handle, thread handle, process ID, thread ID. Startup info, structure to specify how the new processor's window is displayed and initialized. Num children, a constant defining how many children process to create. Num set initializes each startup info and process information structure to the 0 for every child process. Ensure cleaning starting values. Start info size of start info. Set the CB field to the size of the startup info structure as required by the create process function. And next topic is explained by Guru Shankar.
Thanks to Rohan dear. Now my topics are adjust child process and wait for all child process. Prepare arguments for child process. A string is formatted using printf, which includes the name of the child program, followed by two arguments. The starting index of the array segment and the size of the array segment. The create process functions is called in a loop of create multiple child process. Each child process runs the program. Child program fails, it prints an error message using fprintf with the error code retrieved from get last error and exits the program with a return code of 1. Wait for child process to finish. After all process the creator, the program enters another loop to wait for each child process. To complete execution, it uses wait for single object with the infinite timeout, ensuring the main program pause until the current child process. It finishes the preparation of arguments of child process. Now my friend Rohit Idgi will proceed. Thank you, Guru Shankar. As you see line number 63, merge sorted arrays. This line allocates memory dynamically for the result array that will sort the merge result for all sorted arrays. Array size. This is permanently constant or macro that represent the total size of an array you want to allocate for number of elements. And the size of int. This gives the size of one of the integer in bytes. It used to allocate the appropriate amount of memory for the array. As we see the function malloc, it allocates the block of memory the specified size on the heap. Here you are allowing enough space to hold array size integers. This is a result pointer to the first element of the dynamically allocated memory, which is sorted in the result way. And merge sorted arrays. This merge arrays function call is intent to merge multiple sorted subarrays into a single sorted array. Backslash asterisk pass each sorted segment. This is a placeholder which comment where you need to pass an array of points. The num children specifies the number of children arrays that you want to merge. It's an integer that represents how many sorted subarrays you have. The result array, which specifies that this is the array where the merged result will be sorted. It's an array that was dynamically allocated earlier. Array size. This is a total number of elements in the result area. The likelihood the total number of elements across all the child arrays. It tells the merge function how much space there is to store the memory. And stop. As you see line number 67, this is the line unmaps the previously mapped shared memory view from the address space of the calling process shared array, which means that this is a pointer to the shared memory that mapped into the address space earlier in the program. This function calls removes that mapping, free upping the resource associated with the shared memory. The function unmap view of file is used to release the virtual memory region that was previously mapped to a file or shared memory. This is a part of proper resource management when dealing with inter-process communication or shared memory. The close file mapping handle, which specifies the function calls closes a mapping handle. This was used to access shared memory. HMap file. This is a handle to a file mapping object which represents the shared memory region that was previously created using create file mapping. The function close handle is used to release his handle after you are done using it, ensuring no memory or resource leaks, freeing dynamically allocated memory for main array. The free main array. The purpose of this line is the memory that was previously allocated for main array. The main array is preferably dynamically allocated array, likely holding the unsorted version of your data. The free function is used to release the allocated memory back to the heap, so that can be refused. Failing to call free on dynamically allocated memory can lead to memory leaks. The free result array. The lines frees the memory that was allocated for result array. The result array is the dynamically allocated array where the merged result of sorted arrays is stored. After you are done using it, calling fees result array releases the memory back to the heap. It's crucial to free any dynamically allocated memory to prevent memory leaks and ensure proper resource management. Returning from main, return. The line signifies the successful completion of the main function and the program, and it is standard way to indicate that the program executed successfully. And as you go on line number 83, void generate random array. This function populates an array with random integers. Int array, this is a pointer to an integer that will be populated with random values. Int size is used for number of elements in the array that need to fill with random values. And the for loop is used to run size items, iterate over each element of the array. And the rand function generates the random integer which is assigned to the ith element of the array. Rand purpose specify random integers which can be used to simulate random data. And this is a placeholder function that should contain the logic to merge multiple sorted arrays into one.
The int arrays, this is an array weight of pointers to integer arrays. Each array in arrays is a sorted subarray that needs to be merged. Int num area, int num arrays, this represents the number of sorted arrays in arrays that need to be merged. Int result, this is the array where the merged result will be stored. It must be large enough to hold the elements from all the subarrays. The int size is used, this is like to the total number of elements across all the subarrays that will be merged into the result array. Thank you. The next conclusion will be concluded by the Rupesh Chaudhary.
This program provides an insightful example of how parallel computing can be employed to enhance the performance of compuna- computationally demanding tasks like sorting large data sets by dividing the array into smaller sub-arrays and assigning each to a separate child process. The program takes advantage of multi-core processors which can execute multiple tasks simultaneously. This approach is beneficial for applications where sorting large volume of data is required, as it reduces execution time by distributing the workload. The use of shared memory The use of shared memory allows for efficient interprocess communication, enabling the parent and child processes to exchange data without duplicating it in each process's memory space. While the sorting logic within the child processes and the merging of the sorted subarrays are left as placeholders. They are crucial components of the program that would finalize the sorting process. In a fully implemented version, the merging step could be achieved through efficient algorithms like K-way merging, ensuring that the entire array is currently ordered. By extending this framework, one can achieve a robust and efficient parallel sorting solution power that scales with the size of the data and the processing power available, making it a valuable tool for real world applications involving large scale data processing. And I would also like to thank everyone for hearing us. Thank you.